Okay, so here we are in the last lesson for section 4.1, and we're going to do one more graphing and then we're going to talk about types of solutions. So for this one, they are already both in slope-intercept form. So this one is going to have, hold on, let me change my color. This one will be a slope of 1, and we'll write that over 1 to graph y-intercept at 0, 5. And then on the second one, I have a slope of -2. Oh, I want to write that in a different color, so I'll wait a bit. Let's just graph this one. So we're going to have a point at 0, 5. This one is up 1, right 1, down 1, left 1, down 1, left 1. So we can kind of do a few of those, and then you can have more going in the other direction also, up and over, but I know the slope of the next line is negative, so I'm thinking that we're going to end up somewhere else than where we, further away, I guess I could say here. Whoops, let me try that again. It's a little crooked, but I think I'm just going to leave it there so I don't have to draw it again. All right, so on the next one, we have a slope of -2, and we write it over 1, so we have rise and run. The y-intercept is at 0, -4. So we're going to graph at 0, -4. Now for this one, because I need to go toward the blue line, I'm going to use a slope of, oh boy, I'm going the wrong direction. Here we go. We're back. Okay. I'm going to use the slope of 2 over -1. So I'm going to count up 2, left 1, up 2, left 1 again, up 2, left 1, and there I am on that line. This allows us to find our intersection quite easily. And if you can do this, this is kind of how you want to do it. Keep counting until you get to that line. And if you see you need to go in the other direction, then just switch places with your negatives. Or if it's a positive slope, then they both are negative. Oh, why does it have to do that? Oh, I'm touching this with a ruler, so all kinds of crazy things are happening because I'm trying to draw a straight line. When I used to make my graphs in college, I always used nice tools. I had graph paper and rulers, and so it worked out very nicely. So now we are going to name this point of intersection, and that is a solution of -3, 2. And there we have it. Okay, so that's the last graphing question. Now we're going to check to see if, what kind of solutions do we have? Are they the same line? Are they parallel lines? Do they intersect at a single point? And how many solutions does the system have? Okay, so on this first equation, if I put it in slope-intercept form, I'm going to subtract the 3x, so I have y equals -3x plus 1. All right, so I have a slope of -3, and my intercept is at 0, 1. And on this one, I'm also going to subtract the 3x and then divide by 2. So each place I divide by 2, and y is -3/2 x plus 3. So you see that my slope is -3/2. I forgot to do that in a different color. So what this means is that these lines are intersecting lines, and so on part A we're going to say intersecting, and part B, and that would be one solution. All right, next. Okay, so on my first equation, if I subtract the 3x, I'm going to have y equals -3x. So I have a slope of -3, an intercept at 0, 0. On the second equation, let me do this in a different color. I'm going to have y equals negative 3x. So you notice that we get the same slope. And these both have the same intercept. So that means they're the same line. So in part A, I say identical lines. And then on part B, that means that there will be an infinite number of solutions. And that's because they're the same line, so pretty much they're intersecting everywhere. Infinite number of solutions. Okay, so that's it for that one. Next. So you can see the second equation is already solved. It has a slope of -2 and an intercept at 0, 1. On the next one, I'm going to subtract the 2x, right, on both sides. So I get, hold on, let me go back and do this in a different color. Subtract 2x. Y equals -2x plus 0, so we don't write the 0. So we have a slope of -2, and our intercept is at 0, 0. So this time we have parallel lines, because parallel lines have the same slope but different y-intercepts. And then on solutions, well, parallel lines never intersect, so these will have no solution. And so you can actually do this. You can see what's going to happen with your equations even before you graph them. So if you're graphing parallel lines, they should stay an equal distance apart and never intersect. And that can happen on the graph, or you can tell just by looking at the equations. So I hope you enjoy systems of equations. Bye.